Alloy steel. So any steel other than carbon steel is called for alloy steel. So alloying elements of in alloy steel is nickel, chromium, vanadium, magnesium, vanadium, copper, borium and cobalt material. So in this alloy steel, the maximum presence of manganese is 1.6 percentage, copper and silicon is 0.6 percentage. Okay. So exist one or more elements from these alloying elements. So the common properties of alloying elements is it is a high hardness and strength and toughness material, more wear resistance material, high hardenability, corrosion and oxidation resistance is high, improve the measurability of the material and reduce the cracking and warping properties, and improve the flexibility in surface and heat treatment process, improve the ductility and enhance the magnetic and electrical properties of the material. This alloy steel is classified into three types. Okay, classification of alloy steels is the low alloy steels, so medium alloy steel and high alloy steels. So alloying elements less than 5% is called for low alloy steel, is the AISI, and HSLA steel is the one type of low alloy steels, and medium alloy steel is the alloying elements is 5 to 10%, and high alloy steel is more than 10% of alloying elements. Okay, in this carbon content is maximum less than 1% for all the cases. Okay, the carbon content is less than 1% for all the low, medium and high alloy steels. Okay, in this low alloy steels, the alloying elements less than 5%. Okay, less than 5% is the periodic alloy steels is normalized structure containing eutectile perlite. So the examples of low alloy steel is 40 cr, 30 cr mn SIA, 42 cr ma various grades mo, 12 cr mo, 4130, 862 is the various grade of low alloy steel material. Is the properties of low alloy steel is improve the strength, enhance the welding properties and corrosion resistance. In these applications, oil drilling platforms is earth moving equipments, the pressure vessel and pipes manufacturing, construction equipments and the structural steel material is the HOI 80, HOI 90 and HOI 100 steels is particularly using for submarine, off-road vehicles and bridges and the chip hull. Okay, manufacturing areas. And the so low alloy steel is two categories, AISI and HSLA steel. AISI is American Iron and Steel Institute. Okay, this is mainly used the steel is machine construction. It is called as a construction steel or structural steel material. So less than 5% alloying element is a nickel, chromium, vanadium, magnesium, vanadium, copper, borium and cobalt material. So AISI 343 40 steel is one type of AISI steel. Okay, AISI 434 steel. So is the properties high toughness, strength, high wear resistance, especially in hardened conditions. Okay, is a hardened condition is a high tough strength and wear resistance material. Is mainly used for high stress parts manufacturing, so railway components manufacturing for heavy load applications, high shock and impact resistance component manufacturing. So another category is HSLA steel, high strength low alloy steel, is a micro alloyed steel, is called micro alloy steel. Okay, is the micro alloying elements of aluminum, titanium, vanadium and niobium. Low carbon content. So carbon content is a range of 0.07 to 0.13% is the low. It is also called for construction steel or structural steel material. HSLA steel mainly used for weight reduction through increased strength. Okay, low weight and low high strength. It is twice the strength of the plain carbon steel. It is a twice the strength of plain carbon steel material. It is the ductility, malleability and toughness and weldability enhanced by low carbon steel. So higher strength to the weight ratio is achieved. Carbon makes harder and alloying elements make solid strengthening solutions. Is the martensitic or magnetic transformation is a complex carbide, small grain size, high corners. Okay, is the martensitic or magnetic transformation is the complex carbide is formed during the martensitic magnetic transformation. That small grain size is need to increase the high corners of the material. 0.2% of copper improve the corrosion resistance in the alloy steel material. Is a fine acicular ferrite or a ferrite perlite structure is the characteristics of HLS is a high yield strength, improve the weldability, very light material. So it is the 20 to 40% weight saving through without compromising the strength, high ductile, formable, machinable and corrosion resistance material. The fine grain structure by adding is the alloying elements is mainly used in the structural applications of bridges, towers, large scale buildings, columns, pressure vessel, trains, automobiles, pipelines and offshore structure, rail car components. Is the medium alloy steel is alloying elements in the range of 5 to 10% alloying element. Alloying elements and offers improve the durability, strength and wear resistance of properties. So mostly used alloying element is nickel, chromium, molybdenum, manganese, vanadium and copper. Is the main applications of the medium alloy steel is used for gear, crankshaft and axles manufacturing. The hydraulic liners is mainly for automobile side. The gears, crankshaft, axles, some connecting rods, hydraulic cylinders in the hydraulic industries, the ball bearings manufacturing, wind turbine axles, and oil and gas industry. Okay, manufacturing. The high alloy steel is high alloy steel is the more than 10% alloying elements. Okay, the carbon content is less than 1%. The high alloy steel is less than 1% alloying element. It is in the room temperature after normalizing austenitic and martensitic or precipitated carbides is formed. Okay, in the room temperature after normalizing martensitic or precipitated carbides. The alloying elements is nickel, chromium, molybdenum, magnesium, vanadium and copper. Is the examples 4140 4340 is the example of alloy steel of high alloy steel material. It is properties is enhanced strength and hardness and wear resistance and corrosion resistance. Okay, it is stainless steel which contains a significant amount of chromium as well as is well known is the okay. So in the stainless steel material, so particularly in the stainless steel material is a large amount of chromium present. So almost for the almost up to 20 to 25% of chromium presence in the stainless steel material. So is examples. So is applications mainly used in the aerospace, automotive and construction industries, energy and power generation industries for like turbine, boiler and nuclear reactors for heat and corrosion resistance purpose. So oil and gas and chemical processing industries. The high alloy steel is classified into two types. So tool and die steel and stainless steel material. So tool and die steel. Okay, and another one is stainless steel material. Tool and die steel material is mainly used for hardenability, wear resistance and resistance to soften when heating. So tool steel is mainly for chromium based, molybdenum based, cold work steel, hot work steel, high carbon, high chromium steel materials. Okay, molybdenum, tungsten based tool steels. So another one is stainless steel is mainly used for corrosion resistance purposes. Of three categories. Only is for austenitic stainless steel, martensitic stainless steel, ferritic stainless steel materials. So it is mainly used for corrosion resistance purpose. Okay, is the presence of chromium is almost 20, maximum 20 to 25% of chromium. This chromium is mainly purpose main used for corrosion resistance purpose. Is the corrosion resistance for mainly for environmental corrosions. Okay, so in this chromium in the coating, okay, in steel material, this chromium is react with the environmental oxygen is form the chromium oxide. This chromium oxide is protect the corrosion, okay, from the environment. This chromium is one of the alloying elements is from chromium oxide that protect the corrosion from the environmental. Okay, is the stainless steel is the classification of alloy steel is the low, medium and high alloy steel material. Thank you.